For your homework this weekend, you're going to be looking at whether things are proportional or not. We did a warm-up earlier this week about looking at that idea of proportionality. But now we got to figure out, if I'm given a relationship, if I'm getting a set of ratios, are they proportional? When we're looking for proportionality, we're going to look for two things. The first thing we want to look at is, one, do we have outer rainbows? And when I say outer rainbows, we're looking for this idea of repeated addition. So if you can find a common and constant, we're squeezing that addition in there, we're getting that common and constant addition happening across both tables for both different units, we have our first step of proportionality. Second thing you're looking for is inner rainbows. And what that means is a constant multiplier between your two units. And I'll show you a couple examples of where that works and where it doesn't. So make sure when you're looking for proportionality, 1, outer rainbows, and 2, inner rainbows. You need both of them in order to be proportional. We have a payment of dollars per hour. So the first thing we're looking for, do they have outer rainbows? When I say outer rainbows, we're looking first at our dollars. We're looking for that repeated addition. From the first step to the second step, I'm adding 11. Second step to third, adding 11. To the next one, adding 11, and then adding another 11. That shows me repeated addition of a constant number. Every time it's adding 11, 11, 11. Then we go back to my other unit, which is hours. Now, do I have that same outer rainbow relationship? Do I have repeated addition? Plus 1, plus 1, plus 1, and plus 1. So now I've held true for that first statement, that both of them have outer rainbows, they have repeated addition for both of their units. Now we're looking for that second idea of proportionality, which is the inner rainbow. And this is the idea of connecting the two units, and is there a constant multiplier for every step along the way. This first step doesn't show us much because 0 times any number is going to be 0, so it doesn't give us an idea of a constant multiplier. It could be 0 times 20, 0 times 50, 0 times 5,000. So that first step doesn't tell us anything. So we're going to move forward and see if we do also have that constant rate of that constant multiplier between our two units. 1, looking for 1 times something equals 11. Well, I know 1 times 11 equals 11. So now for these to be proportional, every step along the way should have a common multiplier of 11 between hours and dollars. Does 2 times 11 equal 22? It definitely does. 3 times 11 is 33, and 4 times 11 is 44. Because we have these constant rates of these constant multipliers in between our two units, this checks out. Yes, this is proportional. As we had outer rainbows that were consistent, repeated addition, and constant multipliers in between the middle to give us a proportional relationship. Let's look at one more relationship. Looking here, now this one, we have a starting value that is at 0 hours worked, you've already earned $10, and then every step there you're making $5 more. So if we look for repeated addition, that first idea of proportionality, plus 5, 15 plus 5 is 20, so again plus 5, 20 plus 5 is 25, and plus 5. We're increasing by 5 every step along the way, and our hours are increasing by the same constant rate each time as well. Every step along the way, they're going up 1. So every time the hours grow by 1, dollars grow by 5. Step 1 of proportionality, done. Now we got to check for that second step. Do we have something that we can multiply by in between our two units to always be consistent? And this is where this first step comes into play and gives us a big hint. 0 times something should equal 10. And we know that's going to be impossible. Anytime I multiply anything by 0, it's always going to be 0. There's no way I can take 0 times some number to equal 10. That just cannot happen. So that's a big note, that this is not going to be proportional. We check along the way, and 1 times 15 is 15. 2 times 15 does not equal 20. So that now does not work. Now we have 2 strikes against us. We had this one example and these 2 examples. We have no rate of constant proportionality or a constant multiplier between our two units. This one is not proportional. This relationship not proportional. We have outer rainbows, but we don't have inner rainbows, making it not proportional. Use this for your homework this weekend. Check out this video to make sure that we can get those ideas of proportionality, and best of luck. Come to me with questions for MLT.